These days, one word drives high-tech: creativity. If nothing else, NASA's robotic refueling mission, RRM, is creativity embodied. And like all things creative, it's not without challenges.
It's not loading groceries into your shopping cart. It has to be more precise. It's in a harsher environment. It's going 18,000 miles an hour up in space.
Spacecraft usually travel to orbit like museum pieces. They're not meant to be fiddled with once they're hung in their final destinations. But satellites are machines, and like all machines, fuel runs low, parts wear out. RRM set out to prove that robots could repair them in space without placing an astronaut at risk. It's really hard to do, full of challenging problems.
Any problem is a solvable problem.
And repairing satellites in space is not a new problem to solve. NASA has been wrestling with spacecraft on orbit for decades. Early efforts demanded human muscle. In 1984, astronauts captured the Solar Max satellite for an astounding zero-G trip to the doctor. After a little TLC, it went back to work, good as new. The most famous orbital repairs happened with the Hubble Space Telescope. When astronauts paid it a final house call in 2009, the billion-dollar instrument got a new lease on life. Hugely expensive, extremely risky, the Hubble repair mission tested the bounds of human on-orbit capabilities, not to mention cost-benefit analysis. But mission success reinforced the value of on-orbit repairs, and the Great Hubble Space Telescope continues to operate to this day. Complex machines, satellites are neither easily built nor replaced. Refueling and repairing them in space just makes sense.
Robotics can do things that humans can't do in terms of precision, in terms of control, holding a particular spot for 6 hours while engineers on the ground debate what to do. We can't ask a human to do that.
Will robots make astronauts obsolete? Not a chance. And the reason why is pretty awesome. Think of a car like this, in for repairs. A mechanic can slide underneath, try to reach tough spots. But with a mechanical lift, repair options expand. Machines like this, like robots, act as enablers rather than replacements. Robots free astronauts from certain time-consuming and risky operations. Astronaut time is better spent on command and control issues, as well as valuable research and exploration. Robots can also travel places astronauts are not likely to go.
Other projects have been out to geosynchronous orbits and have spacecraft there, have been there for years. So we know what materials work there, we know what the environment is there, and we can use that information to then build on what we're going to do when we build our spacecraft to go there.
As NASA prepared to launch the final space shuttle, the Satellite Servicing Capabilities Office pressed forward with an idea, a test, designed to see if robot technology was up to the job. In 18 months, the team designed the essential RRM experiments, getting hardware built, launched, and installed on the International Space Station.
We had the very aggressive schedule to launch in 2011 to make it on the last shuttle flight, which we succeeded in doing.
So we always say here that we want to test as we fly. We want to test, and test again.
They did. The team completed a series of delicate maneuvers, custom robotic tools, standing in for astronaut fingers. RRM's to-do list looked easy. Unscrew this, cut that, refill a tank like pulling up to the low-octane pump. Right? No, not easy at all. Day 2, in fact, came to a halt halfway in the middle when engineers overseeing the robotic arm had some concerns. A crisis?
It certainly caught our attention, but it was not a heart-pounding moment, not by any stretch.
And that's the thing about missions like this. They demand the best from teams, and people don't get on the team unless they're willing to bring their A game. On day 6, the team put 3 years of planning to work. With ethanol streaming into a tank on orbit, engineers watched the data stream back to Earth. There wasn't much to see, but that wasn't the point. It was a first. Word came over comms loud and clear.
FDS, you would agree that we have fluid transfer in process?
no cheering yet. The team was still in the mission, and there were still jobs to do.
And T4 9.95. Almost done.
Finally, simulated fuel transferred, the team moved to detach the valve.
Whoa.
Real experiments often yield interesting results.
I don't think anybody expected it would stay liquid that long.
But after so much hard work, some things are just to be expected. NASA's reasons for doing this work go beyond the obvious. In fact, the deeper value for the nation is ingenious.
I don't want my job to be refueling communication birds for a living. I truly do not. I want to do it one time, kickstart a commercial industry that can then do it competitively.
This work helps open the door to a whole new kind of aerospace business. Big business. Engineering in space. Inventive. Daring. Smart. And RRM delivered them all. But the big picture? There's only one word that will suffice. Creative.
If you think RRM was incredible, I mean, you guys haven't seen anything yet.